Hey guys, welcome back to the channel. In this video, we'll be talking about dividing rational expressions. This will be our final example for the rational expressions portion of the playlist. So like we said in the past, P over Q is our rational expression. Alright, and so it's really similar to multiplying, but there's an extra step involved. Alright, so this is really needed, like I said in the past, for understanding the transformations of the rational functions once we get into that later. So let's just hop right into it. So in the third grade, when we learn how to multiply and divide fractions, so when we learn how to divide fractions, we had 3 over 5 divided by 2 over 4. Okay, an example of that. Okay, so pretty much what we did was we copied. We copied this piece right here. The first fraction stayed the same, and then we multiply by the reciprocal, or so we change this division sign to a multiply sign, and we flip it. So then we flip this the second fraction, and essentially we are multiplying by the reciprocal. So then we say, okay, now we have 12 over 10 is our fraction. And oops, you guys can't see that. My bad. 12 over 10 is our final answer. And then there's another case with multiplying fractions. If there's anything common, they cancel out. Actually, this reduces down a little bit to this one reduces down to 6 over 5. All right, now if we have 3/5 time divided by 1/10. Okay, well, same steps involved. This 3/5 stays the same. Then we multiply by its reciprocal, so we change the division side to a multiplication side, and then we flip this 1/10. So the 10 goes on top, the 1 goes on the bottom. So that's the definition of a reciprocal. Okay. So 3 over 5 times 10 over 1, and we said in the last video, any factors that come in, anything that they have in common, so 5 and 10 have a 5 in common. This 5 becomes 1, and this 10 becomes a 2. Okay, and essentially that comes from them dividing 5 out by 1, 10 divided by 5, and there's just a factor of 2 left over, and essentially this becomes 6. Okay, well, same case for our division. So the first thing we want to do is we want to, so in this case, my bad guys, I haven't even write out the example. I'm jumping the gun. Minus 4 over x squared minus 4, and we're dividing by x squared minus 3x minus 4, and we're dividing that by x squared plus 5x plus 6. Remember, this fraction bar means division. Okay, and we need that for a future video. Alright, if we have this fraction bar, that means division, but alright, we're keeping it this simple right now. Just, alright, we're keeping this spread out like this. So now we have, alright, so like in the last video, we're going to factor everything out. So, alright, so we're going to rewrite everything. So x minus 4. Alright, so we're going to factor out the denominator. It factors out because it's different as squares. Alright, it's a special case of a quadratic, where if this is a perfect square and this is a minus, and we have a square, well, it factors out as x plus 2 and x plus 2. That's a difference of squares, and we'll go into it a bit more. And then we multiply by its divide by its numerator. Alright, so, or divide by the second fraction, and we're going to factor out again. Alright, so this one factors out. So the question is, what multiplies out to -4 but adds up to -3? Alright, so because this is negative, there has to be a negative and positive. Alright, so we do know, x and x. Alright, this factors out 4 and 1. That's the easiest way to get 3. So x minus 4. Alright, so x minus 4 will give us that, and x plus 1 would be the result of that. And then we have x squared plus 5x plus 6. What factors multiply out to 6 but add up to 5? Well, that's simple. Alright, that's x plus 3 times x plus 2. Okay, with that, alright, and that's not an x squared, guys, my bad. That should not be an x squared. And with that being said, oops, did I mess up? No, I didn't. My bad. We're not done yet. Okay, so now we apply the division rules of fractions. All right, so now we copy this first fraction, keep it in factored form. That's the easiest way to do it. And we have x minus 2, x plus 2. Then we change this division sign to a multiplication sign, and then multiply by reciprocal. Okay. Then we cancel out. You guys can't see that. All right. So we changed. All right. So we kept the fraction the same. Changed this division to multiplication, and then we also flip the fraction. So this x plus 3 times x plus 2 goes up in the numerator, and this goes in the denominator. The x minus 4 times x plus 1. And now we cancel out any factors that we have in common, like we did in yesterday's video. Or in the last one. I'm not sure when these go up. Alright. And so now we multiply this. And so that becomes 1 here. That becomes 1 here. That becomes 1 here. And that becomes 1 here. Alright. It's actually best to use different color pens when you guys are taking notes on this. So you guys could keep track. I just currently have just plain black. Okay, so now what's left? Well, we have an x plus 3. And then we have an x minus 2. And an x plus 1. Okay. Alright, there really isn't any shortcuts to these. These just take time to work out. So our final result is x plus 3 over x minus 2 times x plus 1. Once you guys are able to do mental math with them, these become really quick though. So with that being said, guys, we are finally done with the rational expressions portion of this playlist. And in the next video, we'll be talking about complex fractions. We'll see you guys next time. Bye-bye.